Section 6.4, logarithmic functions. All right, we have finally reached logarithms. Okay, so there are 3 sections left in this course, 6.4, 6.5, and 6.6. 6.4 and 6.5 are going to teach you all about logarithms, and then in 6.6, you will have all the tools you need to solve complex logarithmic functions and complex exponential functions. So that is the plan, okay? I don't know how many of you have seen logarithms before or learned them before. When I was in school, I was never taught logarithms, so there is a chance that, you may not have seen this before. It is a tricky topic for students, so hopefully, just keep practicing until you get the hang of it. It's really not terribly bad as long as you understand the definition of a logarithm, okay? So there's several different types of logarithms. We are going to start off by talking about something called a common logarithm. So in that first bullet, I ask, what is log of 100? Okay. Well, the answer is going to be a number. Okay, so let me make that clear. Okay, so log of 100 is going to equal a number. Okay, the first thing I want to emphasize to you is that a logarithm is something you do to a number. Okay, so I'm going to write that up here. A logarithm is something you do to a number. Okay, it is an operation. Okay, it is like taking the square root of a number. Okay, if you have 9 and then you take the square root of 9, you get a different number. You get 3. Okay, so the same thing is going to happen with a logarithm. Okay, if I have 100, I take the log of 100, I'm going to get a number that's different from 100. It is something you do to a number. Okay, it is not just a symbol. Okay, all right, so if you've never seen this before, let's just consult the trusty old calculator. Okay, so like I said, there's several different types of logarithms, like tons of different kinds. Okay, on your calculator, there are physically only 2 logarithm buttons. Okay, your calculator, depending on what kind of calculator you have, your calculator may be able to do other types besides the ones that are on the keys. Okay, you just have to kind of investigate the calculator you have. Okay, or you can always email me or ask me in class about your calculator. Okay, all right, so what you should see here is an LOG button, which happens to be what we have right here, and you also have an LN button. Okay, this is common logarithm, okay, which is the LOG. LN is natural logarithm, and we're going to get to that on page 3 of these notes. Okay, so if we need to know what this is, okay, and we're not sure, we've never seen this before, all you're going to do is hit log of 100, okay, and it's going to tell you that the answer is 2. Okay, like I said, the answer was going to be a number, okay, and it is. Okay, so the answer is 2. Okay, that's the answer. Okay, so how would I know how to do this without a calculator? Okay, well, here's the deal. Here's what a logarithm is. Okay, let me show you the next page. Okay, the next page, page 2 of the notes. Let's look at some of the logarithms on here. Okay, so if you notice, all of these guys on page 2 have this teeny tiny number associated with them. Okay, so this one's got 2, this one's got 4, this one's got 1/2, 5, and then the square root of 2. Okay, this teeny tiny little number is called the base of the logarithm. So this is a base 2, this is a base 4, this is a base 1/2, base 5, base square root of 2. And if you go back to the one we were just working with, the common logarithm, okay, you don't see a teeny tiny number. Okay, and here's why. It's a common logarithm. It is so common, it has a button on your calculator, okay? And it's so common, you're expected to know what that teeny tiny number is, okay? The teeny tiny number is supposed to be 10, okay? So you could also write it this way, okay? You can write in the base, okay? With common logarithms, you are going to just see log. You're not going to see this little subscript 10 with it. You're expected to know that, okay? The teeny tiny number is called the base of the logarithm, okay? So a common logarithm, when it says log, it is a base 10 logarithm, okay? So common logarithms, and I'll write up here, these are base 10 logarithms. Okay, so the reason this answer is 2 is this, okay? I am trying to figure out, well, let me do it this way. Let me go back and take this off. Okay, we know the answer is 2, but here's why. All right, your answer is going to be a number. You are trying to figure out what power do I need to raise the base to get this other guy. Okay, so 10 to what power gives me 100? And the answer to that is 2. 10 squared is 10 times 10, that's 100. So that's why the answer is 2. Okay, this arrow thing is going to be your best friend when you're doing logarithms. Okay, all a logarithm is doing, no matter what the base is, your answer will be a number when you're trying to find a logarithm. You're trying to figure out what power do I need to raise the base to get this big number. That's it. Okay. One thing I want to point out before we go through the rest of this page. Okay. Had I taken my calculator and instead did natural log of 100, okay, you're going to get a totally different answer. Okay. So you need to be very cognizant of what kind of logarithm you're doing. Okay. This ln or natural log, we're going to talk about that, like I said, on page 3. It is not base 10. It has a different base, okay? So when you're using log, you have to use base 10 and the appropriate button on the calculator, okay? All right, so second bullet point here, it says logarithms with base 10 are called common logarithms, okay? And this thing in the box, this statement in the box, is outlining it's summarizing what I described in the arrow diagram. Okay, or I call it the arrow method or arrow diagram here. Okay, if you see this statement, and remember, if it's log, you're not going to see the little 10 here. Okay, most of the time you're not going to see that little 10. Okay, so log base 10 of x is equal to y. Okay, which can also be written as log of x is equal to y, omitting the base here. This is an equivalent statement to the base to this power equals this. So 10 to the y power equals x. Okay? So the arrow thing is going to be really handy. Okay? All right. Here's a very important statement. Okay? 2 functions here. F of x equals 10 to the x, and g of x is equal to log x. This is actually a function. You know, you could put both of these in your calculator and look at their graphs. Okay, I know, especially the log function, it's not something we use all the time, so it may be a little unfamiliar to you. Okay, but if you were to take these 2 functions, 10 to the x and log x, and put them in your calculator and graph them, they're going to be reflections of each other about the line y equals x. They are inverse functions. They undo each other. Okay, so keep that in mind. Okay. So in doing so, you know, remember, this exponential has base 10 and this logarithm is base 10. Okay, so if you have a simple exponential function, okay, and a logarithmic function of the same base like this, simple logarithmic function, they're going to be inverses of each other. So like the function 2 to the x and log base 2 of x, they're going to be inverse functions. 3 to the x and log base 3 of x are going to be inverse functions, and so on. Okay. All right, so let's do some more practice with logarithms. Okay. So in example 1, you've got 4 of these here, and there's 2 columns. There's a logarithmic form and there's an exponential form. Okay, now I'll explain the difference. The directions say find the exact value of each logarithm, then change each logarithmic statement to an equivalent statement involving an exponent. okay? All right, let's just start with part A, and so then I can explain the difference between these two blanks, okay? All right, so all of these are LOG, okay? So they're all going to be base 10. If you notice, none of these have the little teeny tiny subscript there to remind you that it's base 10. When you see LOG, it needs to click with you that this is base 10, okay? All right, so if it helps you, you don't have to, but if it helps you, go ahead and write in the base, okay? So my base is 10. So again, the answer is going to be a number. What power do I have to raise 10 to get this number, okay? And the answer is 4, okay? And you can confirm that on your calculator, okay? If I put in log of 10,000, I'm going to get 4, okay? So that's the answer here, okay? Now, this exponential form thing, okay? Basically, you're explaining yourself, okay? That's how you can think of it. Why is this logarithm? Why is the answer 4? It's 4 because if I take the base and raise it to the 4th power, I'm going to get 10,000, okay? So both of these statements, the logarithmic form and the exponential form, are saying the same thing, okay? They're just written differently. This one is a logarithmic statement. The log of 10,000 is equal to 4. And this is the exponential form. Notice there's no logarithm in here. You've got an exponent, okay? 10 to the 4th power is equal to 10,000. They are saying the exact same thing, just in different formats, okay? So again, the answer to the logarithmic form is just going to be a number, and the exponential form is, think of it as you're explaining yourself why this logarithm is what it is, okay? All right, so again, let's look at this one, okay? The log ones are great because you can plop them in your calculator, but you should understand why you're getting what you're getting, okay? So the log of 0.01, okay? Again, your base is 10, okay? The answer is going to be just a number. I'm trying to figure out what power do I need to raise 10 to get 0.01, okay? So if you start running powers of 10 through your head, okay, 10 to the 1st power is 10, 10 squared is 100, 10 to the 3rd power is 1,000. So positive powers are not working for us, okay? 10 to the 0 power is 1 because anything to the 0 power is 1, okay? So probably negative powers here are going to work, okay? So I'll just come over here, maybe. 10 to the negative 1. Remember, that is the same thing as 1 over the something, change the sign of the exponent. So this is 1/10, okay, which is 0.1, okay. 10 to the negative 2, okay, that's 1 over 10 to the negative 2, change the sign of the exponent. This is going to be 1 over 100, which is 0.01, and that's what we're looking at here, okay. So the answer is the negative 2 power, okay. Okay, if I do 10 raised to the negative 2 power, I'm going to get 0.01. Okay, you can confirm that on the calculator. Okay, what is the log of 0.01? Negative 2. Okay, all right, so keeping with this, okay, part C. Again, it's another common logarithm. The base is 10. Okay, what power do I need to raise 10 to get 1/10? Okay, so we did that up here. Okay, it's going to be the negative 1 power. Okay, so the answer to this logarithm is negative 1. All right. Okay, and again, like I said, you can check on the calculator. So log of 1/10 is going to give you negative 1. Okay, last one. Okay, this one is strange. Okay, I'm trying to figure out what power I need to raise 10 to get the square root of 10. Okay, I'm going to go ahead and put this one in the calculator because you may not know this. Okay, so the log of the square root of 10. Okay, All right, remember, you don't have to put the base in the calculator because log means base 10. You're going to get 0.5. Okay, so the answer is 0.5. Okay, so if I take 10 and raise it to the 0.5, which is also the fraction 1/2 power, I will get the square root of 10. Okay, so I'll put here, you can either write 0.5 or 1/2. Okay, this is actually something very useful that's really going to help you in the next section. Okay, if I take 10 and raise it to the 1/2 power, I'm going to get the square root of 10. Okay, so this is something pretty cool. The square root is equivalent to the 1/2 power. So if you're taking the square root of something, it's equivalent to the 1/2 power. If you're taking the cubed root of something, it's equivalent to the 1/3 power. If you're taking the 4th root of something, it is equivalent to the 1/4 power, and so on. Okay, 5th root would be the 1/5 power, and so on. Okay, I mean, seriously, if you said 25 to the 1/2 power, 1/2 power is the same thing as the square root of 25. Okay, raising something to the 1/2 power is equivalent to taking its square root. Okay, and so that would be 5. Okay, this will come up again and again in the next section. Okay, so make sure you take note of this. Okay, all right, so the answer to this last logarithm is 1/2. Okay, all right, last thing on this page, there are some properties of common logarithms. Okay, so I'm going to fill in the blank, and I'll probably give you an example of at least these two because they have variables. I'll give you an example below it. Okay, all right, again, these two you can just plop in your calculator because they don't have variables. This will be a little different. Okay, but you should know how to do them by hand again. Okay, so I'm going to go down here. I'm trying to figure out what the log of 1 is. Okay, so remember, I'm going to write in my base. Okay, I'm trying to figure out what this equals. Okay, so 10 to what power gives me 1? Okay, the only thing I can raise 10 to get 1 is 0. Anything to the 0 power is 1. Okay, so the answer to this logarithm is 0. Okay, you can confirm that on the calculator. The log of 1 is 0. Okay, all right, next one. Okay, what does the log of 10 equal? I'm going to write down my base. Okay, I'm just rewriting the statement with a base on it. Okay, so again, all this is saying, if I take my base, what power do I raise it to get this big number? Okay, 10 to what power gives me 10? Has to be the first power. Okay, and again, you can confirm this on the calculator. Like I said, if you forget these particular properties, you can figure it out on the calculator. Okay, all right, so here comes another one. These last two have variables. Okay, all right, so I am trying to figure out, I'm just going to rewrite it. Log base 10 of 10 to the x equals what? Okay, same thing. If I take my base, what power do I have to raise it to get this quantity? Okay, the only way these two sides can match is if it is equal to x. Okay, so this is x. Okay, this one, okay, remember what I told you up here, that the functions 10 to the x and log base 10 of x are inverse functions. They undo each other. So if you see a log and a 10 like this side by side, they're going to cancel each other and leave you, the x will come down out of the exponent. Okay, that happens because they're inverse functions. Okay, so like I said, I'd give you an example of this. Okay, so if I gave you log of 10 to the -7, okay, the log and the 10 would cancel and the answer would be -7. Okay, all right, this last one, okay, this is actually an exponential with a logarithmic exponent. Okay, so you can't really do the arrow thing here. You can only do the arrow on a logarithmic statement. Okay, but you can use what I just told you. The 10 and the log are side by side. They're touching. There's nothing in between them, okay? So they're going to cancel and leave you with x, okay? So an example of this is going to be if I told you 10 raised to the log of 6 power, okay? The 10 and the log are side by side. They will cancel and leave you with 6. All right, so now we're going to move on and take a look at logarithms with bases